Thank you very much, Liz. I want to introduce myself. My name is Victor Juma. I'm business manager for Syngenta Professional Solutions in East Africa. And also want to extend a warm welcome to all our participants today in our second series of webinars. In today's series, we'll focus on water volumes. Last week, we focused on spray penetration and coverage. Next week, we shall focus on adjuvants. And in today's webinar, we have participants across East Africa, drawn from Kenya, Ethiopia, Uganda, and Tanzania. In our panel today, we have two speakers, Mr. Ruud Robben, who is based in the Netherlands and is a crop application expert for Europe, Africa, and Middle East. And then we have Mr. Mark Freysen, who is based in our Basel office in Switzerland and is responsible for application trials across Africa. And both Ruud and Mark are no strangers to East Africa, so they know the terrain very well and they understand our cropping culture and our crops. And I would also want to introduce our local team. From Ethiopia, we have Mr. Biruk Melese. We have our technical manager, Daisy Ngeno, Daniel Weremba, Geoffrey Muyomba, and Kennedy Onyango, our team of crop advisors. And as you can already see, all participants are on mute except the panelists. And we have a chat section on the Q&A. So you can post in your questions, comments, or feedback on the Q&A section, not on the chat section. And I know last time we had a lot of questions, but we shall try our best to answer the questions as they come. So feel free to start posting in your questions so that they will be answered towards the end of the presentation. If you have any technical issues, again, you can post in the Q&A and we shall try and see how we can address them. And lastly, we are recording today's webinar for the purpose of future reference and also to share back during our trainings. So thank you very much, and I would like to leave the floor to Mr. Ruud Robben without further ado.
Well, thank you, Victor, but I think the first that will start doing the presentation, the first part is done by Mark. But I want to welcome everybody. We're talking about water volume, dose rate, and determination. And the first part will be done by Mark Freysen.
Thank you, Ruud. Good morning, everybody. Yes, today we will speak about water volume and dose rate and calibration as well. And we spoke last week about this penetration and having an homogeneous coverage. And this is completely linked to our topic from today with water volume determination. Next slide, please. Okay. Today, we know that we have to adapt the right water volume to the canopy. What we want is to have a homogeneous distribution and uniform distribution on our target, on the leaves in terms of penetration and in terms of the right water volume coming on the leaves. And what we want is to avoid our runoff. Runoff is losing water from the leaves, and if we are losing water from the leaf, we are losing our compound. That's what we don't want. And for sure, what we want to avoid is any contamination, first from the applicator, but as well from the environment, because we don't want to pollute our environment or having any contamination from the applicator. In fact, the water is only here to carry the compound and to bring this right dose rate on the leaves where we want to have this compound. And in fact, we have a tool to help us to determine this right water volume. And this tool is called leaf wall area determination. And this calculation should help us to calculate the right water volume linked to the canopy. Because in fact, often the growers think more is better. What does it mean? More water is better. More water we are bringing on our crop is increasing the level of more water is giving us a higher concentration maybe, or a higher protection of our crop, and this is not the case. Next slide, please. And the question is for you now, what water volume do you currently use to control red spider mites?
So you should see that now up on your screen. So you just need to select one of the options. No votes yet. Oh, there we go. Go for you. I was worried it wasn't working.
Okay. That means
Quite a fair split so far.
that pond mildew is between 500 and 1,000 liters, 42%. Spider mites, yeah, high water volume.
Yeah. 30% of people feel
Yeah.
are greater than 2,500.
2,500, 2,000 to 200, 2,500.
Yeah, it's high.
Almost 50% of the people are using really high water volume.
Yep.
Because
But it's different for powdery mildew. It's lower.
Yeah, but
which is good.
That's good. But in fact, everybody is thinking. A lot of people are thinking more is better, mainly for insecticides. And I guess all these people can see the water dropping from the leaf in this case.
Mm-hmm.
I think we can end the...
Yeah, I think that's good.
Okay.
Excellent.
That really high water volume are used in this case.
So I will do the next poll because it was a question also in. But you had the answers already, Mark. So I'll continue.
Okay. Can you remove the pool, please, from the screen?
You have to close that. I've just shut mine.
My screen. Yeah, sorry.
Yeah.
Okay. Back to our slides, and here we have trial results. Here we can see we did some trial on water volume, and we used this tracer technology, which is an UV dye, and we can check the recovery we can find on the leaf. That in this case, we applied with a boom sprayer and we applied with a backpack. And we applied, one is 1,600 liters per hectare. On a second application, we applied 800 liters per hectare with a boom. And in this case, we can see that we increased, reducing the water volume, we increased the recovery from 45%. That's a lot. It's huge. And with the backpack, we had exactly the same picture, that we increased using less water. We increased the recovery of 30%. That means 45 or 30% more compound on the target, reducing the water volume. Next slide, please. Okay, and now the question is how to determine really the right water volume using this level area calculation. And in this case, what we need to check is the level height in meter. That means what is the size of my crop and what part of my crop is targeted for my application. That means, for example, here, we said the level height is 1.5 meters. This is an example. And what we should know as well is the row spacing, middle row to middle row. That means here, in our case, we have a band, a roses band from 1 meter, and we have a trial, an application trial where the grower is working from 0.75 meter. That means band middle row to middle row, we have 1.75 meter. In our case, for this calculation, we need to apply or we need to calculate on 10,000 square meters. This is our reference. It's 1 hectare. And on the calculation, we can see level height in meters times 2. Why times 2? Because we are applying both sides from the crop band. We need to apply both sides from the crop band and divide by the row spacing. That means in our case, 1.5 level height times 2 times 10,000 square meter. That means 1 hectare, divide by 1.75 meter. And this is giving us 1,742 square meters level area on 1 hectare. This will be the reality. This is the reality in our situation. That's the first calculation we have to do to find out the right water volume linked to our crop size. Next, please. Here, it's just to explain you the row spacing measurement. If you would have a single row, for example, in veggies, or you have a double row or in veggies, it's like a double row is like you in roses. That means you have a large row of crop, and it means it's the distance between the middle of the row, your crop row, in fact, middle to middle plus your try. Next, please. Next slide, please. Okay. Why we spoke about veggies on the previous example? It's because we are using the knowledge we have about veggies. We did a lot of trial as well on veggies and on roses, and we find out that we can compare the results we get on veggies and on roses. And in our case, the water volume, you need a reference water volume linked to a level area surface. And in our case, the reference water volume is 400 to 500 liters for 10,000 square meters level area. This is our reference. Next slide, please. Okay, again, now we know our level area surface, and we know our reference. Our reference linked to veggies is 500 liters for 10,000 square meters level area. Again, our row spaces is 1.75 meters. Spray band height 1.5. Again, we have our calculation, 1,742 square meters level area. And now we know that 500 liters is linked to 10,000 square meters. That means we want to know which water volume is linked to 1,742 square meters. And the easy calculation we can see on the example is that this is giving us 800 57 liters per hectare should be used to apply 1,742 square meters level area. That's what we should use to apply in our field. Once we know with water volume, we can use the dose rate used for an hectare. That means, for example, 1 kilogram switch per hectare, you have to mix with 1 kilogram switch in 857 liters. In fact, we could adapt a little bit the dose rate, but this is something we have to fine-tune a little bit for the moment in roses. You can adapt a little bit linked to the crop size, but in our case, for the moment, in roses, we don't know exactly the maximum and minimum, mainly the minimum dose rate we can use. That means we don't want to give you any recommendation which could bring you in a wrong situation. That means for the moment, please use your normal dose rate per hectare. Next one, please. Okay. Once we know our water volume, now today we calculate the water volume. We know we measured our level area. We calculate the water volume we need, and now the next step for us is to calibrate our material. And we can calibrate our material like if we would use a boom sprayer calibration. Because in fact, we are applying 1.5 meters high. In this case, it's linked, in my example today, it's linked, for example, we are applying right and left, okay? It's linked to 6 nozzles. Why it's linked to 6 nozzles? Because my spray swath on one nozzle is 50 centimeters, okay? That means we have to know the spray swath of our nozzles. That's something really important to understand. If you want to calculate really, if you want to calibrate properly your material, you need to know the spray swath of your material. You need to know as well what the level you want to apply. For here in this example, we are speaking about 1.5 meter. But for example, if you would only apply the top of your crop, that means the part you have some roses. In this case, you would only apply maybe 50 centimeters. That means in this case, your level would be only 50 centimeters, 0.5 meter. Can you come back, please, Ruth, to the slide with the level calculation?
This one?
This one, for example. Here, we said our level is 1.5 meters. That's the complete crop size, because we want to apply, for example, a fungicide on the complete canopy. That's the first the example we are using. What you have to understand pretty well is that the level area is linked to your application level. That means if you want only to apply the top part, you have not to use 1.5 meters, but maybe only 50 centimeters. Thanks, Ruth. Can you come back to the... Okay. Then here, back to our nozzles. We want to apply 1.5 meters high. That means for us, in our case, 50 centimeters spray swath, it's equal to 6 nozzles on a boom sprayer, right and left. That 3 right, 3 left. And what's important for you to understand as well is the spray swath has to be checked on your own field. That means here, maybe in your situation, with the angle you have and the distance between your nozzle and your canopy, you would maybe only have 30 centimeters spray swath, or 25. If you would have 25, if you would measure 25, in our case, it would double the number of nozzles. Okay, that's a theoretical situation. Next one, please. Okay, now we said we know in the theoretical situation how many nozzles we would use regarding the level we are applying. Now, first of all, we have to calibrate our speed. And calibrate our speed is not adapting the speed to the water volume we want to apply. Because in fact, the problem is if you are adapting your speed to the water volume, you would never be able to keep the same speed for a long time. It's why we all time say, please check your own application speed, and after that we will adapt the material to your own application speed. In our case, the applicator would apply 3 kilometers per hour. It's pretty easy to check. You have a distance. In this case, we are using 100 meters, but you can use 30 meters or 50 meters. That doesn't matter. Multiply by a factor which is giving you kilometers per hour, divide by time. That means distance in meter, divide by a time in second, multiplied by 3.6, because this is giving us a result in kilometers per hour. Next slide, please. Okay. Once we know, in fact, now we are on a point, we know our speed, we know exactly the volume we want to apply. The row spacing is spacing is something we know as well, because we used it for the level area calculation, and linked to the level area application, we know, and linked to the spray swath for our nozzles, we know how many nozzles we should use in a theoretical situation. Okay, the factor of 600 is here because we are using kilometers per hour, and we are using liters per hectare, and we need a result in liter per minute to choose the right nozzle. Okay, and here the calculation is giving us 1.25 liters per minute and per nozzle. Okay, once we know the flow rate we want to achieve, we have to choose our nozzle. And from the last week presentation, we know today that we have to avoid all droplet size under medium. That's something we want to avoid. That means we should use air induction application, air induction nozzle to apply our crop in order to increase this droplet size. And in our case, for example, if we are giving a look on this table, we can see with an 0414 bar, it will give us 124 liters per minute with a green nozzle with coarse droplets. And that's what we want. It's something around medium to coarse droplet size. That means the droplet size is good enough, and the right flow rate is 124, 125. That's good enough for what we want to do. Okay, now we have everything. We calibrate everything. We know the water volume, that we just have to check the right water volume. How to check the right water volume is on 1 minute, just checking the flow rate on 1 minute, and to check as well in same time the right pressure to adapt the right pressure. If you have not 1.5 liters per minute on your check, that means you have to maybe adapt a little bit the pressure, or maybe you have to clean the nozzle, or you have maybe to increase a little bit the pressure on your pump. Yeah, but that's the target now. Next slide, please. Okay, so you have another solution to calculate effectively the flow rate you need, and this is often the case in the real life, that you have a water volume, that the water volume is again the water volume you calculated before, linked to the level area you want to apply per hectare, and linked to this 500 liters to 10,000 square meters level area we find out doing many trials in the previous years. Your speed is still the same as before, because you checked your speed, and your speed was 3 kilometers per hour. That's something, it's not changing. Row spacing again, crop bond again. That means your crop bond is still 1 meter. The row spacing is still 0.75 meters. And now we are taking an example that we want to apply a 30-meter bond on one side. For example, that's our example today. If you are applying a 30-meter bond on one side, you need to apply 30 seconds to apply 26.25 square meters on soil surface. The question is how to find out this soil surface. That means the 30 meters long you want to apply, multiplied by your row spacing plus your crop bond, divided by 2, because you are applying only one side. I hope this makes sense for the moment for you. That means linked to the water volume we have to apply per hectare soil surface, that's 857 liters, you would apply on this 26.25 square meter soil surface, you would apply 2.25 liters water. But what we need is to link this to a flow rate per minute. And this 2.25 liters on 36 seconds would be equal to 3.75 liters per 60 seconds. That means 3.75 liters per minute. But what we know is, can you come back to the slide with the 6 nozzles, please, Ruth?
This one?
Here, yes, exactly. But we said 3.75 liters per minute. But we know that to apply, in our case, this 1.5 meter, we would apply 3 times 50 centimeters spray swath. Then, in this case, this 3.75 height has to be divided by 3 times the spray swath. That means 3.75 divided by 3. Can you come back to the previous slide? Here, in this case, 3 times the spray swath, 50 centimeters. That means 375 liters per minute applied on 1.5 meters. That means 375 divided by 3, which is giving us 1.25 liters per minute flow rate, which is exactly the same as before. Can you come back to this previous slide, please, Ruth? And here again, we find out 1.25 liters per minute and per nozzle. That's exactly the same. It's two different ways to find out your needed flow rate on a nozzle. I'm speaking on one nozzle because, in fact, if you are applying, I know that you are often applying with two nozzles on your lance. Why I'm only speaking about one nozzle? In fact, why are you using often two nozzles? It's to increase the water volume and to create more mist. From the previous presentation last week, we understood that we don't want to create mist. That's something we have to avoid. From the today presentation, the first slide, we have seen that we don't want to increase too much the water volume. That means two nozzles are not needed really for these 2 points that create mist and increase the water volume. We don't want to these two. We don't want to be in this both situation. And another point is, in fact, you have a spray cone which is giving you a spray swath. You can easily imagine to have, if you have two nozzles catching each other, just maybe 5 centimeters from each other, your both spray cone are not anymore really spray cone because they are touching each other. And if each spray cone is touching each other, that means your droplets are also catching each other. And what we want in this case, what the situation in this case, your droplet size is increasing. You are heavier droplets, but they are falling much faster. That also it's not what we want. We want to optimize this spray swath and to have an homogeneous spray picture. And to get this homogeneous spray picture, we need to optimize our spray cone. And to optimize our spray cone means only using one nozzle per lance. I don't know if it's really an understanding, but we will come back on everything if you have some question. That was from my part. Now I will give the hand to Ruud. Thanks, Ruud.
Yes, thank you very much, Mark. I think a lot of people will think it's a difficult calculation, but you can go through the presentation later again and understand what Mark exactly means, because a lot of figures that's coming along. But I think it's a good way to show what we think about the water volumes, and perhaps that you can adapt a little bit more to maximize your water volumes, but stay on the edge that it is not too much. That comes to me that we say, oh, it's nice, but it's not comparable. We have big differences. When you look at a sprayer back in the field, it's an example of this case the UK with a width of 36 meters and a spray, and it can adapt the speed as much as he wants. So it's really easy. But you have to spray manual by hand, and you can't run 12 kilometers an hour with spraying like the device in the UK does. But okay, that we understand that completely. We did also last year some trials in the Netherlands with a atomizer to spray in roses, and the nice thing was, in this grower also applied 4,000 liters per hectare to control, for instance, powdery mildew. We did some application trials, and afterwards he told us, when somebody told me a year ago that I would reduce water volumes to 1,000 liters per hectare, I would say that he would be crazy. But they started to adapt their water volumes to lower it, to use less water. to do the applications in cut houses. So we have some examples, for instance, when you look at the water volumes in different crops. In general, we see that in ornamentals, where this is the speed that people apply the products, and the water volume is in between 1,000 and 4,000 liters per hectare. But what about outdoor crops? Outdoor crops, they also have to spray, and they also have dense crops in a lot of cases, and they only can spray from the top. What water volumes do they use? Well, that can differ from each country. We start with Japan, where the fields are, in a lot of cases, just smaller, and they apply about 1,000 liters per hectare. And we go to the Netherlands, where they use about 200 to 400 liters of water in open field vegetables, but also crops like potatoes or cereals. When we look at the United Kingdom, the speed is higher, and they use about 100 to 200 liters per hectare. But then you come to Australia even, they drop the water volumes to 30 to 50 liters per hectare. And also this has a reason. In ornamentals, it's always in greenhouses, or a lot of cases in greenhouses, where the water availability is not really limited. It's available via pipes. When you spray outside, you have to carry the water to the field. So that makes you think about, perhaps I should reduce a little bit the water. And this is a real extreme case in Australia, where they use 30 to 50 liters per hectare. But it's also a reason that they want to reach the other side of the field with one tank. And that brings it to this really low water volumes. So it's always the right balance between maximum efficacy and a runoff. Water, what Mark already mentioned, is only the carrier to get the active ingredient at the right place. So if you create runoff, which is here indicated, the active ingredient is not there anymore. So the water doesn't do its job in the right way. When you look at formulations, when you look at a product, we have a formulation. It's not only the AI what you're spraying, it's a complete formulation which is created around the active ingredient. And one of the main products is the adjuvants, built-in adjuvants. And the weaker the dilution, the weaker the effect of the built-in adjuvants and solvents. So when you dilute this product 1 liter in 1,000 of liters, or you dilute it in 2,000 of liters, how big do you think the effect of those built-in adjuvants will be? Well, they will drop also tremendously. And this will result in a lower presence of the AI on the leaf surface and less efficacy, of course. Again, I want to show you a high-speed video, and it's again 5,000 pictures per second. We show it in 50 pictures per second. So it means we can visualize exactly what's happening on the leaf. In this case, you will see at the beginning of the video, the droplets nicely land on the leaf surface. In the middle of the video, the leaves are completely saturated, and it means the droplets will bounce off. This is something you can never see in practice when you're spraying, even when you would have your eye on it, because it's happening too fast. And that's why we can nicely show this by showing you this high-speed video. So here the first droplets will come, and I will try with the pointer to show you what is happening when droplets were landing and when they will bounce off. So there are droplets coming. You can see the first droplets here are nicely landing on the leaf surface. Here you can see there, here, everywhere, the droplets are landing on the leaf surface. And now somehow you saw the first one is bouncing off. The leaf area is already saturated. It's full. There they are coming. And perhaps it's the best way to show it here, where there you see the droplets flying down. Here it is. There it is. There they are. There they are. Everywhere. More and more droplets were bouncing off. You see them here now everywhere, coming, falling down the leaf. I can't point every droplet anymore because it's too much. And that's what's happening. In this case, you're only spraying with 1,000 liters per hectare. And it's done with a boom sprayer, with a track sprayer, which mimics just a boom sprayer out in the field. And it does precisely the 1,000 liters per hectare to cover the leaf. And this is, in this case, too much. The next video will be a video of what is happening after spraying. We didn't do that with a high-speed video. We did that with just a little bit more pictures per second and do it in a normal speed so you can see what is happening. But it's easily, you can easily see it when you spray it yourself. But it's happening a few minutes after you're gone, after you left the crop. So this was the spraying. We have to be patient, but then when you look, you will see the droplets disappear. They will collect to each other, and it doesn't matter which kind of droplet size you use, it always will happen. They will collect because they are that close and it's that much that it's getting together. They get together and just they make a river in the veins of the leaf. So here's the first one, first candidate to leave, I guess. We have to be patient for this one, but you will see that it will happen. And this is always, I think, always happening always in the greenhouse when you use high water volumes. Just think, there it was. There's the next one. Just remind yourself when you are ready by doing your spraying. Can you hear it dripping in the greenhouse when you're ready? Then this all is happening here. And this here, what here is sprayed is the fluorescence dye with only water. There is no adjuvant in that helps the spreading. So it could be even get worse than this one. There's one leaving. This will come. I think this is it. It shows exactly what can happen. So what is good coverage? Do we like this one or this one? If you look closely to this leaf, you will see that there are a lot of nice droplets on the leaf. It's nicely, fantastically covered. This was done with 600 liters per hectare. If you see this one, this was too much even. It was saturated again. It was done with 1,200 liters water per hectare. And the runoff, as showed earlier, was observed. So this would be good, and this one wouldn't be that good. We did also some trials in Kenya. We looked at the standardized tracer deposits on the leaves. As Mark already mentioned, we spray tracer as a fluorescence dye, which you use to spray and measure depositions on the leaf and also the coverage. It helps us to understand, to see how much of the applied product we can really find back on the leaf. We always apply this with a percentage dilution, so it's 0.1%. And we know exactly how much we applied because of the water volumes. And then we can see how much of that we can find back on the leaves. You can see that we had an average deposit of more than 3.5 with 750 liters. When we apply 1500 liters, it will drop. When we apply 3000 liters, it will drop even more to 2 nanograms per square centimeter, which indicates the grams per hectare. We can also show that in a different way, and that's the tracer recovery. So it means from the applied percentage of AIs, how much of the percentage we will see back, we will find back in our measurements. So when you apply 750 liters per hectare, and that's something Mark already also showed, you have a recovery of 68% of the AI you applied. When you do it with 1500 liters, it's only 45%. And when you do 3000 liters, it's only 40%. So 60% ends up in the air or in the soil, what you don't want. That's really something you have to bear in mind, and you have to think about. Then we come to a next poll. Is water availability an issue for you?
So you should have that up on your screen now, everyone.
Yes. So until now, 2/3 doesn't have any issue, and 1/3 has some water issues, availability.
Yeah, I think that's a pretty fair split.
Yeah. Okay, we see that 2/3 doesn't have any issue. 1/3 has some water availability issues. So that could be a good one, especially for those farms, to bear in mind what we already told. What brings us to the rest of the presentation. We have some recommendations for you. And first, of course, and I think everyone can imagine that, avoid runoff, optimize water volumes, and make calculations as in the example, just to have an idea on what I'm really doing. Am I doing the right thing by using this high water volumes? Or should perhaps I reduce? Make a calculation as an example, learn from it. Create a constant application speed according to the application, to the calculation. So you have an idea, when I walk in this speed, I do a nice application. I use only one nozzle to optimize a spray cone. An air induction hollow cone nozzle, please. And consider future upgrades of spray equipment, which means perhaps using an atomizer in future. A last poll. Will you consider adjusting your water volumes accordingly? Now I'm curious. Yes. Okay.
A couple of people have definitely been listening.
Do you see it, Mark? The results? Makes me really happy.
Yeah, that's good. That's really good.
Awesome.
That means they understood that this water volume is really linked to the amount of compound you will bring on your crop.
Exactly. And that's really on your crop and not somewhere else where it isn't supposed to be. And that's a good end of the presentations, and to go to the questions. So I would say Asante Sana, and put your questions in the Q&A, please.
So yeah, we've already got a couple in here, Ruud. So concentration, i.e. grams or mils per litre of water, or rate, i.e. kilo or per litre per hectare?
I don't know where you're talking about. When we talk about the fluorescence dye we used, it's a concentration. So it's 0.1% per liter water you use. When you look at the rate, from crop protection products, as far as I understood, the registration is in kilograms or liter per hectare.
Exactly. If you are speaking about compounds, the compounds are registered, should be registered in gram or kilogram per soil surface. That means for you, you know clearly that if you want to apply a compound, you are applying per hectare and not per hectoliter or not per liter.
Okay.
That means in our case, from what we have seen today, is you are probably increasing your concentration, because for the moment you applied around 2,000 liters per hectare with 1 kilogram in 2,000 liters. Today we said we have to decrease the water volume and keep the same dose rate per soil surface, that you are increasing your concentration.
So
Okay.
the next question is, can the density of the crop affect the volumes? Well, I think Mark tried to show in his calculations that it is depending on, if you mean that a denser crop should need higher volumes, I think you should more consider about the coarser droplets.
Exactly, to increase the penetration into your crop. In fact, but you have to keep as well your common sense. That means if you know that you increased a lot and you see that you have no penetration, once you change your droplet size to coarse or ultra coarse, maybe you can increase a little bit, but you have to keep your common sense. We said, as if you compare with the trial we did before, if you double your water volume, you will clearly lose some water on the soil and lose some compound. We have seen if you increase too much the water volume last week, is also the problem that you are creating such a shadow in front of your canopy, and a lot of leaves are catching the water volume around the canopy, and nothing is in the middle. That means, please, for the first step, increase your droplet size, and after that, yes, you can think about, but in a certain value.
The next question. Can adjuvants cause runoff in products with EC formulations? Yeah, well, it can happen, and we will come back to that, I think, next week. And it's depending also on which adjuvant you will use. But we'll come back to that next week. I think also when you talk about EC formulations. But it's a good topic for next week.
Okay, so the next one there.
The size of the canopy affects the volume of water used. Yes, it is. If your crop leaf wall is only half 0.75 meter, for example, in our case, you would find only half of the water volume to use, around 400 liters per hectare. That's clear. That means the leaf wall area is linked to the size of your canopy or the size of your application leaf wall. Okay? And in our case, we said the quantity of AE per hectare is linked to a soil surface. and we said we will not change the quantity of RE used today. We just increase we just decrease the water volume, but we keep the same dose rate.
If I am using biologicals, does the presence of big chemical droplets on leaf surface affect them? I presume you mean microbiologicals, so beneficials. I think it's depending on which type of chemical you used. And for a certain amount, even when you use water, it will affect, but it's really depending on which chemical you're using. So it might be, it's depending on.
Okay, spray application technology, assume mechanical boom spraying, yet most applications in Kenya is manual or as greenhouse flows are in. Okay, in fact, no. We used Ruth, could you come back to the slide with the nozzles, please?
1 second, I have to see if I. Which one you mean?
The slide, you know, with the 6 nozzles, right and left, 3 and 3.
This one.
Okay, yes. Here we said we can calibrate like a boom sprayer. Does not mean that we are using a boom sprayer, because here we said we are linking our calibration to a 50 centimeter spray swath. That means one nozzle is one single lance in this case. And you are swinging up and down with your single lance, you are anyway applying 1.5 meters high. But 1.5 meters high, sorry. So if you are swinging, is 3 times your spray swath if you have a spray swath for 50 centimeters. That we are using the spray boom calibration way, but in the end, what's important for you is to know your spray swath and the level you want to apply, and how many times you can divide your level by your spray swath.
I think the next question is also for you, Mark.
I have to open the question Q&A again. The calibration was for no.
That calibration was for a boom sprayer used on field crops like veggies. How
Yes.
about hose and reel for roses?
That's the same. We said we from the trial we did in for many years, we can compare the veggies results to the roses results. That means the calibration is the same.
Good. Does higher water volumes mean better coverage in contact products? Well, it's not the case, because your higher water volumes have less concentrated product in it. And when you lose a lot of product, then you have also it's gone, it's disappeared. And when you see the runoff, the water is collected on the edges of the leaf, where it can even cause some phytotox. So it's not really nicely spread. No.
In fact, it's double pain, because you are decreasing your concentration, and you are as well decreasing the volume of water coming on the leaf due to the runoff. That means it's double pain. Increasing the water volume is double pain.
Just to add something, Mark and Ruth.
Yes.
My definition of coverage then would mean the number of droplets you actually applying per centimeter squared per unit area. So the way I would measure coverage is in the deposition, like you discussed, and also how much of it is retained on the leaf. So sometimes there's an argument about whether high water volumes means coverage. But my feedback would be that coverage would actually translate to the number of droplets you're applying per centimeter square.
Exactly. When what we showed in the video also, when you have too much droplets on that centimeter square, you will lose them.
Yeah.
Also, bigger droplets leave chemical residues on the leaf surface, which is not good for customers. What should I do? I don't know what you mean exactly, but when I apply bigger droplets, they will leave chemical residues because we're spraying this product. When you have systemic products, when you have bigger droplets, there's more time for the AI to get into the leaf. So from that perspective, it isn't on the outside of the leaf anymore, which would be good. What should I do? Yeah, I don't, perhaps it would be better if there was a better description what you mean exactly, because you want to have your chemical on your product to control your pest or disease. So it should be on. But if you have a systemic one, bigger droplets take care of a better uptake in the leaf.
Maybe we have more information next week about this topic.
Does the pH of water in general? No. There are some buffers built in the formulations, and that the influence of the effect of the pH is really limited. But again, there's also the buffer is also just a tiny concentration in the formulation. If you use higher water volumes and the concentration will drop because of this higher water volumes, the impact of the pH buffers will also drop.
Okay, can pressure affect volumes to be used? Clearly, that means we have seen last week that increasing the pressure is increasing the water volume and decreasing the droplet size. That's clear. And it's why to get the right flow rate, you need to use the right pressure. That means in our case, we have seen that we want to reach 1.24 or 25 liters flow rate per minute. It's linked to 14 bar pressure in our case. And this is clear. If you want to reach the right flow rate, you need to use the right pressure.
Systemic and contact AI's water volume remains the same. Yes, you should just have a nice coverage of her leaf, not too much and not too less. So from that perspective, I would say, yeah, the water volume should remain the same.
That means what you can play with is the droplet size. You can maybe, for a systemic compound, increase a little bit your droplet size to coarse to ultra coarse, and using maybe medium to coarse for for contact compound.
In case I want to do full coverage, will increasing water volume affect the efficacy of the product, given that I maintain the amount of AI per hectare per area / hectare? I want to do the full coverage.
In fact, the point is really this runoff situation. You have to take care about this runoff situation. As soon you have runoff, it means you are losing compound. The calculation we give is an easy calculation to be sure to stay on the safe way in terms of runoff and contamination and everything.
And you have the ideal coverage. Yeah.
Exactly.
Because what you want to do is you want to stack the droplets on top of each other on the leaf, and that's not possible with water. So it will drop off. No open questions anymore.
No, so that was all the questions. Thank you very much, everybody. I think if you've got any other questions, just get in contact with the local team. I'm sure they can help you out and
There's a
point you
question.
in the right direction. Oh, now there's another question.
Most of the systemic chemicals have been blacklisted on EU market. The likes of Meserol, Metomax, and Regent. What new products do you have? We want to add this news as soon as possible. As we have new products registered, we will come back to that. I think at the moment to get a registration during COVID-19 Corona period is pretty difficult, but we're working on it to get as soon as possible new products, and we have some nice things in pipeline for you.
Good question.
Very good question. Very good question.
Okay, lovely. So I think that's everything. I hope you've all enjoyed the webinar. As Victor said at the beginning, this has been recorded, so it will be uploaded. So you'll be able to access the information again. And once that's live on the website, I'm sure the team will communicate that out to you so you know you can go and get hold of it. Okay, so and just a final thing, some of you I know have already registered for our final webinar, which is next Thursday, which is all about adjuvants. So I hope you will have some time to listen to the third one in the series, and make sure you come and find us online, Twitter, Instagram, and on the website as well. Thank you, everyone.